Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 3 of lesson number 10, Gravitation. Now in the lesson, in this lesson we have discussed so far regarding who was Sir Isaac Newton. That was the last part that we had discussed, right? And apart from that, we even discussed one universal law yesterday, if you all remember, right? And that universal law of gravitation is very important for you to know. Okay, so and even we discussed on some basic things on gravitation. So before I proceed with the lesson further, I want each one of you to please revise each and everything that we have discussed so far, because revision is very important and I want each one of you to do that. Okay, starting from whatever notes you have taken in your book, you need to revise each and everything. I hope every one of you have started revising it. So we have started this lesson by discussing about some basic things on gravitation and how exactly the idea of gravitation has hit like Newton's mind. That also has been given over here, right? So I want each one of you to please go through the slide properly, like have a quick revision of the slide. After this introduction, we had this activity 10.1, which you can even perform according to me. So I hope many of you might have performed and have visualized the circular path, like how the stone was moving. So when you do that, you'll understand it properly, that how a stone moves with a velocity of constant magnitude. Okay, so if you all have not done it, I'll request every one of you to please try and do this activity, because like it will help you to understand the motion, the circular path in which the stone is moving. Then after this activity, we started our discussion on universal law of gravitation, where we have two different objects as A and B, and both the distance, like both the objects are at distance from each other, and we represent that distance as D. Okay, and as you can see, there's a formula that has been given in figure 10.2, that is equal to, like, force F is equal to, that capital G is like, you can say it's the gravitational constant that we have, and according to the universal law of gravitation, force is directly proportional to the product of their masses and is inversely proportional to the square of the distance between them, right? So on the basis of that, we have considered the mass of object A as capital M, and the mass of object B as small m. Okay, so that is how we get the formula as F is equal to G, that is the gravitational constant, capital M is the mass of the object A, small m is the mass of the object B, divide by d square is the distance between the two objects. So I just want each one of you to please go through the slide once, and then I'll show you the other slide as well. I hope every one of you are going through the slide and you're even understanding the figure that is being like shown. After this we discussed on like how can we derive the formula, right? So I just want each one of you to please go through it. I hope everyone is going through this slide because this slide is very important again. So please go through it properly. After this, we discussed on like a short information on Sir Isaac Newton, who exactly he was and what exactly he was doing, right? So he was born in a poor farming family, but he was not good at farming. It's like, earlier there used to be a tradition where the son used to do the same thing that the father used to do. Okay, so like his family was like for like all were doing farming, but Isaac Newton didn't had much interest in farming and he was not good at it as well. So he went to study at Cambridge University in 1661, and then in 1665 a plague broke out in Cambridge. So because of which like Newton has to take a year off, and during like he has not wasted that year. What he did like thankfully what happened during that year itself, an apple fell on his head, like the story how exactly the gravitational force came into existence, how he got the idea on it, right? So apple fell on his head and he started thinking of this incident. So this incident prompted Newton to explore the possibility of connecting gravity with the force, right? So this is how like the universal law of gravitation has come into existence. I hope you all are going through this slide. Then over here we have like some of the theories and what other things like Newton has done, what experiment he was into. Everything has been given on this slide. So I want you all to please go through it quickly. I hope every one of you are going through it. After this, like now we will be studying, like discussing on this example 10.1, like how can we calculate the force exerted by the earth on the moon. So this over here we are going to use the same formula that we have, that F is equal to capital G, then capital M small m upon d square. Now you know how it has been derived, right? So we'll be discussing that in detail. See, the mass of the earth is 6 into 10 raised to 24 kg, and that of the moon is 7.4 into 10 raised to 22 kg. So over here what they have done, they have provided us with the mass of the earth and the mass of the moon. Okay, and there's a difference in both the masses, right? So if the distance between the earth and the moon is 3.84 into 10 raised to 5 kilometer, calculate the force exerted by the earth on the moon. So what they have given over here, they have provided us with the distance between the earth and the moon. What we need to do is, we need to calculate the force that is being exerted by the earth on the moon. And over here, we know that the value of gravitational constant is 6.67 into 10 raised to minus 11 meter square and per kg square, right? So we have to use the formula. The mass of the earth, capital M, we are considering the mass of the earth as capital M, and that is 6 into 10 raised to 24 kg. Then mass of the moon is small m, that is 7.4 into 10 raised to 22 kg again. Okay. Now the distance that they have given between the earth and the moon, that is equal to 3.84 into 10 raised to 5 kilometer. Now what are we doing? We are converting kilometer to meter. So for that we need to multiply this 3.84 into 10 raised to 5 by 1000. Why are we multiplying that by 1000? Because we are changing the unit from kilometer to meter. Okay, so it becomes equal to, because there are 3 zeros more, so 5, 10 raised to 5 becomes 10 raised to 8. We are considering the zeros over there. Okay, and we know that gravitational constant that we need to take is 6.7 into 10 raised to minus 11 Newton meter square per kg square, right? So this is the given information that we have and the conversion that we need to do. Now from equation 10.4, the force exerted by earth on moon. Now over here they have like let us know about the formula that we need to use. Now because we have studied only one formula till now, we are very well aware that what formula we need to use, right? So the formula that needs to be used over here is force is equal to G, that is the gravitational constant, capital M, that is the mass of the earth, small m, that is the mass of the moon, divided by d square is the distance between the earth and the moon. Okay, and then we have to like put on the value and calculate it. Now there will be many calculation, like you might face some difficulty in the calculation part as well. So the answer has been given, but I want you all to do the calculation. See, the figures are given, just use the formula according to the given information, put the values in the formula and then try to calculate it, and let me know if you're able to find out the answer or not, because you should be able to find it out. Okay. I hope everyone is trying to calculate the values. Now what you can do is 10 raised to minus 11, 10 raised to 24, 10 raised to 22. You can keep that separately and do that later. But the values you need to multiply that. Okay? Okay, so I hope every one of you are able to like calculate the thing. And what has been done over here is 10 raised to 24. If you do minus 11 for 24, what will be the answer that you'll get? So minus plus like that. When you calculate it, because you have three different values for 10 raised to, right? One is 10 raised to minus 11, other one is 10 raised to 24, and the last one is 10 raised to 22. So when you do the proper calculation, you will get the answer as 10 raised to 20, and then you can conclude that thus the force exerted by the earth on the moon is 2.02 into 10 raised to 20 Newton. Getting my point, everyone? So I hope you all are clear with this example, because like you will be having many numerical. If you remember, like we have many questions at the back which I have shown you in the last part as well, like because we will be doing that, right? So make sure you are aware of those. Then we have next thing to discuss, that is importance of universal law of gravitation. Now we know what universal law of gravitation is. How can we calculate that? If any like numerical comes on that, we know that as well. But the question is, what is the importance of the universal law of gravitation? So see, the universal law of gravitation successfully explained several phenomena which were believed to be unconnected. Now there were many different phenomena. See, because like there were not much, you can say, information based on all this gravitation, and also anyone coming up with a new concept. There are so many things which were lacking, like which the people didn't had information about, right? So there were some phenomena like which people were feeling that they are unconnected, but that was being proved and that was being explained properly by this universal law of gravitation. So like they came to know that the force that binds us to the earth is the gravitational force. So universal law of gravitation plays a role over here, because that is the force which is keeping us binded to the earth, right? Then the second phenomenon, or the second phenomenon like that people used to feel like they were unconnected, they were not having information, was like the gravitational force is like also helping the motion of moon around the earth. So the motion of the moon around the earth is possible, that is again because of the gravitational force. So this was also clearly explained under this universal law of gravitation. And the third part is the motion of the planets around the sun. Now we all know that sun is in the center and all the eight planets keep on revolving around the sun. So how is this motion of the planets around the sun possible? Now that is again because of the gravitational force. And lastly, the tides due to the moon and the sun. Why is it so? Why are they occurring or happening? That is again because of gravitational force. So you can say when it comes to studying the importance of universal law of gravitation, all the important information that we have received with respect to gravitation, that is been given over here. There are many different aspects as well along with this. So I just want each one of you to please go through it quickly. I hope every one of you are writing this. After this, now we have free fall, which is a short concept that we will be discussing. So let us try to understand the meaning of free fall by performing this activity. Now, what's the activity? You need to take a stone, throw it upwards, and it reaches a certain height and then starts falling down again. Okay, now if you can't find any stone beside you, what you can do is you can take any object, just throw it upward. Okay, and once you throw it upward, you will find out that it will reach a certain height and then it's going to fall again, right? So that is what free fall is. Like this we have already observed that, like that is the common thing that we have, right? So we have learned that the earth attracts objects towards it, right? What the earth does is earth attracts objects towards it, and this is because of the gravitational force. Why is the earth able to attract the object towards it? Because of the gravitational force. And whenever objects fall towards the earth under this force alone, we say that the objects are in free fall. What has been stated? Whenever objects fall towards the earth, when you throw anything up, it is going to fall again towards the earth, right? So whenever objects falls towards the earth under this force alone, we say that the objects are in free fall. Okay, so is there any change in the velocity of falling object? What do you think? Do you think like there will be any change in the velocity? See, while falling, there is no change in the direction of motion of the object, right? The direction of the motion is going to remain the same when the object falls down. But because of the Earth's attraction, there will be change in the magnitude of the velocity. So the direction will not change, but the magnitude will change. Okay, so any change in velocity involves acceleration. So if magnitude is changing, velocity is changing, then acceleration is involved over there. Acceleration means it is going to get accelerated, and there will be a change in the magnitude of the velocity as well. So as I said that whenever there will be change in the velocity, it's going to involve acceleration. So whenever an object falls towards the earth, an acceleration is involved. Okay, so this acceleration that has been involved over here, this is due to the earth's gravitational force. This acceleration is due to earth's gravitational force, and therefore this acceleration is called as acceleration due to the gravitational force of the earth, or acceleration due to gravity. And we denote this acceleration due to like due to gravity as small g. Capital G is gravitational constant. Small g is acceleration due to gravity. So we need to be clear with both the terms. Okay. And the unit of this acceleration due to gravity is same as that of acceleration, that is meter per second square. Okay. So the unit is meter per second square, and we know from the second law of motion that force is the product of mass and acceleration. F is equal to ma, right? We have already studied that force is equal to, force is the product of mass into acceleration. So let the mass of the stone in activity 10.2 be m. What is the mass of the stone? It's small m, and we already know that the acceleration involved in falling object is due to the gravitational force, and acceleration due to gravity we denote that by small g. Small g is acceleration due to gravity, right? Therefore the magnitude of the gravitational force F will be equal to the product of mass and acceleration due to the gravitational force, that is F is equal to mg. What is the formula for F over here? When acceleration due to gravity has been involved, the formula is F is equal to mg. So from equation 10.4, 10.4 is over here. F is equal to, I'll show you. Can you see F is equal to G capital M into small m upon d square? So from this equation 10.4 and the equation 10.5 that we got just now, that F is equal to mg. So from both the equation, we get the formula as mg is equal to capital G, capital M, then small m upon d square. And in short, if we have to write it, what will happen? That the small m and small m will get cancelled. Okay? This small m and this small m, when they get cancelled, we are left with the formula small g, that is acceleration due to gravity, is equal to capital G, which is gravitational constant, then m upon d square. This is the formula that we get, where m, the capital M, is the mass of the earth, d is the distance between the object and the earth. Okay, so let an object be on or near the surface of the earth where the distance d will be equal to capital R. So d that you can see, the distance is equal to the radius of the earth. Okay, so thus for objects or on or near the surface of the earth, we get the formula as, like, instead of d we will write r square. So again we get the formula as g is equal to gravitational constant, mass of the earth upon radius of the earth square. This is the formula that we have for acceleration due to gravity. Okay, now we know that earth is not a perfect sphere, right? Do you think that earth is a perfect sphere? No, right? So as the rate, so as the radius of the earth increases from poles to equator, the value of g becomes greater at the poles than the equator. So as and when you can say like the radius of the earth will increase from pole to equator, the value of g will become greater and greater at the poles than at the equator. For most calculations, what we can do is we can take g, that is acceleration due to gravity, to be more or less constant on or near the earth. So for objects which are far away from the earth, acceleration due to the gravitational force is given by equation 10.7. For that we will be using this. Instead of writing the radius, we will write distance square itself. Okay, so I hope every one of you have understood this. Now I want you all to write all the important points that you can find over here on this slide with respect to acceleration due to gravity. I hope every one of you are writing everything from the screen. I hope every one of you are writing from here. After this, I want you all to write this as well. Wait, let me just clear it. Okay. I hope every one of you are writing it. Now after this, the next thing that we have is like how to calculate the value of G, which I'm not going to start with today. Like we'll be discussing how to calculate the value of G in the next class. Okay, but I hope like you're clear with the free fall concept and the importance of universal law of gravitation. Along with that, like if you get any numerical to solve, how you're going to apply the formula and you're going to solve it. Okay, so we'll start with how to calculate the value of G in the next class. Then we'll even discuss on like the motion of object under the influence of gravitational force of the earth in detail. Okay, so we'll be discussing that as well. Then we will discuss on example 10.2 in detail, like how to calculate the speed, average speed, all in detail. We'll be discussing on all of them. Then we have like another example again, we'll be discussing on that. And whenever it comes to, you can say, gravitational force or any kind of force, mass and weight, these are two important concepts that come into picture. Okay, so we'll discuss about that as well. About mass and weight, we'll discuss about that in detail. Then after that we are going to discuss on weight of an object on moon. Let's say like if you go on moon, what will be your weight on moon? We'll be discussing on that as well. Okay, then we'll discuss on example 10.4 where we will be calculating the weight. Okay, then here we will be calculating the weight on the surface of the moon in detail. Then after that, we will be discussing on thrust and pressure as well in detail, like what exactly thrust and pressure is. And we will be discussing that using two different situations. Okay, so make sure you know it. Then we will be discussing on example again, because as we are proceeding further, there will be many numericals on each and every topic that you can get. So you have to make sure that you are prepared for that. Okay, then after that we'll discuss about like pressure and fluids in detail. Then we have buoyancy to discuss in detail. Now this is a very important and easier concept according to me, but most of the students they find it difficult. So make sure you all like pay attention to it whenever I'm teaching you all. Okay. Then we have this activity 10.4. We'll be discussing on that as well in detail. As you can see, the explanation to that is so long. So we'll be doing that. Then we'll discuss on the concept why objects float or sink when placed on the surface of water. Because whenever you place an object on the surface of water, there's only two probability over there. Either the object will float on water or it will sink inside water. These are the two important possibilities that might happen, that might occur, right? So we'll be discussing that using two different examples. Okay, after that we will be discussing on Archimedes principle. Now Archimedes principle is again very important question, like as we had the universal law of gravitation, same way Archimedes principle becomes very important question for us. So make sure whenever I'm teaching you are paying attention to the activity and you are understanding what exactly Archimedes principle is. Okay, then we'll discuss on relative density in detail, and we'll be even discussing on how can we calculate the relative density. Okay, and then we have the summary discussion for the whole lesson, that is gravitation, which we will be doing in detail. Okay, so after this we have few questions which have been given. Okay, we'll be discussing on that as well. So I just want you all to please go through the questions that have been like that I am showing you on screen. I hope every one of you are going through the question that I'm showing you all on screen. I hope every one of you are going through the question that has been shown on screen. Like, we will be discussing them at the end of the lesson. So if you all know it, like what are the different types of question we are going to discuss, like you will benefit it from it some or the other how, right? So we have so many questions, just like we can we will need one whole, you can say, part for discussing this. So there are total 22 questions that we will be discussing at the end of the lesson, gravitation. Okay, so make sure whatever we discuss today in this lesson, gravitation, you all are revising it, because that is very important. You revising and knowing the concept properly is very important for me, okay, as well as for you all as well, so that you are like able to write the answers and frame your own answers in short. Okay, you should not be looking for the answers here and there. You should be able to write it in your own words own itself. Okay, so whatever part has been left for this lesson, gravitation, I'm going to continue that in the next part. Thank you everyone.